Stability of ground types. The purpose of my project was to determine what ground type would provide the most stability for a house or structure. Earthquakes and other natural disasters can be tragic when it comes to building and families. By experimenting with the use of a shake table and Lincoln logs, we can learn what type of ground will provide the most stability in the event of such a disaster. My hypothesis is that the compacted sand ground type will result in the house remaining standing longer than the other ground types. The amount of time a house stays up during a disaster serves as the independent variable. The dependent variable is represented in that the ground type can affect a house's safety during a disaster. My controls constants are the Lincoln log house and the amount of time and the amount of ground tested, as well as the force the shake table was shaken. For the experiment, I created a shake table and built a Lincoln log house on each of the 5 ground types tested. For the ground types were soil, sand, P-rock, compacted soil, and compacted sand to represent various types of ground a house may be built on. I vigorously shook the shake table for each ground type 3 times over and utilizing a timer, averaged the amount of time it took for the house to fall. The materials I used were 1 sterile type container basin, 23 inches by 16 inches by 6 inches, 3 1-inch PVC pipes cut into 16-inch lengths. Lincoln log house cabin built per instructions. Different types of ground, 1 cubic foot each, soil, sand, and P-rock. To make compacted sand and soil, 1 whole gallon of water per test, 6 gallons in all. Stopwatch or timer. To test my hypothesis, I first filled the basin with the soil, making sure to spread evenly and level. The basin was then set on top of the PVC pipes, equally spaced apart. The Lincoln log house was then assembled in the center on top of the soil. I shook the table back and forth and recorded the time it took until the structure began to fall. I then repeated this 2 more times. I then tested the other 4 ground types 3 times each, recording the time it took until the house fell. For the compacted soil and compacted sand ground types, 1 gallon of water was used, added to the dry soil and compacted sand, then pressed firmly. Once all 15 times were recorded, they were then averaged to determine what was most successful in the house remaining standing.
Go!
My conclusions showed that my hypothesis was incorrect. According to the times recorded during the experiment, the P-rock ground type showed to be the strongest in keeping the Lincoln log house standing the longest time. I observed that as I shook the shake table, the house would sway back and forth and would fall after a very short amount of time. The information from this experiment could be used to keep houses and people safe in the event of a natural disaster such as an earthquake. The purpose of this project was to test different ground types' ability to keep a house and its inhabitants safe in the event of a natural disaster such as an earthquake. The hypothesis was that compacted sand would keep the house standing the longest time was proven incorrect. The experiment consisted of creating a shake table by filling a basin with different ground types, setting on top of cut PVC pipes assembling a Lincoln log house on each ground type and shaking the basin, recording the amount of time it took for the structure to fall. I observed the house would sway back and forth with each shake, and it didn't take long for the structure to fall. In conclusion, the P-rock resulted in keeping the house standing for the longest amount of time, failing to support the hypothesis. I hope you enjoyed this presentation, and thanks so much for your time today. Bye!